Okay, so let's move on to the next rule for differentiation, and that's the quotient rule. And I'll show you the quotient rule really quick. I'll show you how to use it really quickly. Look, you can read this yourself, so I'm not going to kill you with, but all it says is if you want to take the derivative, find the slope at a point of a function that's in the form of f of x over g of x. That's a rational function. That this is what you'll do to get that. And this is really, I keep preaching about this, this is really fill in the blanks kind of stuff. So here's some important things, I think. The first thing is you have to just memorize this. So put it on a flashcard and memorize it. It's not going away. When you take the AP exam, and you will take the AP exam, or you're going to take an exam in calculus in college, your professor or the test administrator is not going to ask you to use the quotient rule. They're going to give you this application, and you're going to realize, oh, I need to use the quotient rule here. But the outcome is not the use of the quotient rule. The quotient rule is just a tool for the application of calculus. So this is what I want to do. I want to look at this way. I want to start out with this function, say find the derivative. So let's try it for a second. Find the derivative, right? Find the slope at a point. Find the derivative of y equals, how about 5x minus 2 over x squared plus 1 is the one we're going to use today. So this is what I'm asking you to do. I'm asking you to see this on your paper, and then see it in color this way and say, you know what, this is what's really going on is that. So this is what's happening in my mind right now. I'm like, you know what, this is my, you see it up at the top there. Here I wrote f of x this way. So what I'm going to do is I'm going to just, in my mind, I'm saying, you know what, this is my f of x right here. And if it's tacky or corny or whatever, then I'm color coding it, sorry. And at the bottom, that's my g of x. I'm going to say, you know, well, that's x squared plus 1. Okay, this is where you can make an enormous difference for yourself. This can really, really help you. I promise that it can. It just seems overly simple, but keep it simple. Keep it simple. So this is what I'm going to do. I'm going to say to myself, okay, I'm trying to find the derivative of this. How am I going to do it? Well, I'm going to use this tool. And to use that tool, you have to ask yourself, what pieces do I need? So what pieces do I need to use this tool? Well, it says here you need f of x, don't you? So you need f of x, right? It says right there that we're going to need an f of x. It also says right here that we're going to need an f prime at x, so we're going to need an f prime at x. These are pieces that we're going to use to build this derivative. It says here we're also going to need g of x, so I'm going to have to gather that g of x. And it also says here that we need g prime at x, so g prime at x. So this shouldn't be confusing. I want to be clear about this. All we're doing here is gathering pieces, asking ourselves what pieces will we need, writing down the pieces we need, and then going collecting the pieces. So it says here clearly f of x, right, is the top piece, and here it is, 5x minus 2. So f of x is just, sorry, I'm going to put it in orange, is 5x minus 2, isn't it? And then we need f prime at x. Well, what is the first derivative of 5x minus 2? And if you're saying 5, and I can hear you, you're absolutely right. Right? Because it says here that we're going to need this f prime at x. We're going to use it up here, aren't we? So we're going to put this machine together in just a second. It also says that we're going to need a g of x, because there's that. And we know clearly, here's g of x right here, right? We have it in this form. G of x is x squared plus 1. We have g of x, and given g of x, we can find its derivative. And its derivative, sorry, that's an x. Its derivative is 2x, right? If you're having any problems with this, you need to kind of go back to more basic rules of differentiation, but I'm assuming you have these rules together. So now all I'm going to do with this is, frankly, like I said earlier, fill in the blanks. What blanks? Okay, no problem. What blanks? These blanks, you guys. Right? Because this is the tool that makes our derivative. So I'm just going to start gathering those pieces together. And it says g of x, right? So we need g of x first. So equals g of x, so I'm just going to plug in. Here it says g of x, so I'm going to put in x squared plus 1. It says times f prime at x. Well, f prime at x is 5. If you don't mind, just visually, I'm going to put it in front. It maybe should have gone here. It says that we're going to subtract here, so this negative sign right here is this one right here, just filling in blanks, right? And it says f of x times g prime at x. Well, f of x is 5x minus 2, isn't it? And g prime times g prime at x, right? And g prime at x, right? And g prime at x is 2x, right? So there's my, whoops, let me put it in green so you can see where I got it from. I'm taking this piece, it's right here, is 2x. Probably should have put it in the front, but who cares for right now. It's going to continue building. And then here it says that I get this. I get something, right? I get this thing, g of x squared. So here's this thing, and here's my square. So this, guys, is just this. And all I'm going to do is go back to my list. See how this list is working out good, isn't it? I'm going to plug this in. It says g of x, so there's my x plus 1 squared. Word of caution. Some of you guys are going to see this, and your algebra teachers did such a fine job with you that you're going to try to do the binomial expansion of this. Don't do it. Don't do it. I'm going to say it again. Don't do it. Wait and ask yourself, is there any reason that you should be doing that? And you have to have a really good reason to do that. So I'm not going to mess with that yet. Now I'm going to simplify here. So let's simplify a little bit. So simplify. So by simplify, this is what's happening with me, is I'm going to distribute here and here. I'm going to distribute here, here. And then I'm going to distribute this. And you know what? If you don't mind, can I do that? Can I move this over here? Move this 2x over here if you don't mind, just so we can see it. It was positive 2x, so I'm going to put it right there. It is. And now it's negative 2x, and I'll just distribute that in. Is that okay? So simplifying this out, we're going to get equals 5x squared plus 5 minus 10x squared, right, plus 4x. Isn't that right? Is that all right? I think that's good, isn't it? And then going to keep simplifying. Oh, Charlotte. Look, and so I'll bring. Wow, sorry about that, you guys. I'll bring this piece down here. This piece here is just this piece right here, right? That's just this mess right here. So I'm just bringing that along. Look, you guys, I think you're thinking because you've done so much pre-cal and you've done so much intermediate algebra and advanced algebra. Well, let's just take a look at what happens. I'm just going to gather like terms. So gather like terms. So gather like terms. X squared gives me negative 5x squared here, doesn't it? Plus 4x, right? Right? Plus 5, right? Plus 5 all over the quantity x squared plus 1 squared. Now let me say this to you, because believe it or not, we're done. So you're saying, well, should I expand this now? It's a really fair question. Why? What are you going to get out of it? So if you look here and you're like, you know what? If I expand this, maybe it'll look just like this and this just goes to 1, or it simplifies out in some other way. If that's your reasoning for why you're going to expand this, then go ahead. Other than that, leave it as it is. Don't change it. All right? I hope that was helpful. Let me just go over some stuff again really, really quickly. First thing is, here, how about I keep it to 2 things quick. 1, memorize this. Then ask yourself what pieces you need and write those pieces down in the form of a list, and then fill in the blanks. Okay, you guys? Excellent work. Hang in there. You can definitely do this. You're going to get great at this.